we're back. We're back and better than ever. So let me see what's in my calculator. Gonna clear. No, I don't have to clear anything out, I guess. Let me turn my plots off. Because I'm sure I've been using this for statistics. So now I want to use it for Algebra 2. So I'm gonna type in this. We know what this looks like, okay? I didn't need a graphing calculator for this. Y equals x squared. Graph. Now, you look, if you ever have a graphing calculator, it's not showing up, okay? So I'm gonna hit zoom 9. Still not coming up. So let me go change my window. It means it's working, okay? I go to my window. I'm just gonna make my standard window negative 10, 10, and 1. Negative 10, 10 and 1. Now when I hit graph, you can see the graph for y equals x squared looks like that. That's what my graph for y equals x squared looks like. So f of x equals x squared. And it looks like this. You guys knew that. Of course you did. Now, let's say I graphed negative x squared. You probably know what that is too. Let me clear that out. Hit a negative, hit x squared, graph, and that's an upside down parabola. Interesting, interesting, okay. So this was y f of x equals negative x squared, okay? Now I'm gonna do f of x equals, say, x cubed. So I go to my y equals screen, I clear that out, I type in x cubed, and I graph it. It looks like this. Interesting, interesting. F of x equals, let's do a negative one of those too. Negative x cubed, graph. Looks kind of like the opposite. Looks like a reflection, doesn't it? Looks like a reflection. Mr. Green would be happy talking about reflections like that. Okay, that's f of x equals negative x cubed. Well, let's look at some other ones. Let's say I had y equals, and I go over here and I'm gonna say, I don't know, let's make it 2 x to the 4th, and then I have minus 6x plus 1, something like that. So f of x equals 2x to the 4th minus 6x plus 1. Ready? Voila. Look at that. It looks kind of like the one that's right next to it, doesn't it? Not exact, but it looks kind of like that, doesn't it? Kind of, sort of, kind of. Now I could do insert. I'm gonna try to insert something here. Second, insert. Let's make that negative. Okay. And now I'm gonna hit graph again. Well, what do you know? Very similar to the one that's next to it. That is f of x equals negative 2x to the 4th minus 6x plus 1. Okay? How about the old line y equals x? We don't have to graph that one, guys. Y equals x. Looks like that. Y equals negative x. Slope is negative 1. Okay, so I'm gonna have you guys study that for a minute. Take a look. See if you can start to make some statements. Are there some statements that we can make? Are there some statements that we can make? Can we say anything is similar? Can we predict what a graph is gonna look like based on what I have written down there? Can we predict what a graph will look like? Okay? That's my question to you. That's my question to you. So if I gave you any kind of function, let's say it said x to the 6th, could you tell me which one that's going to be like? It's going to be like some of these graphs. Which one is it going to be like? If you guessed these, you're correct. Why? My leading coefficient is positive, and my exponent is even. My degree is even. Okay? y equals negative x to the 7th plus 4x to the 6th minus 7. I don't know. I could put anything I want after that first term. What is this one gonna look like, you think? Well, let's look. This is negative, and my exponent is odd. Where do I have a negative leading coefficient and an odd exponent? Well, that's these two right here. Okay, so the point of all of this is to describe what's called its end behavior, how the function ends. Okay, now this is something that I will give you. Okay, I'm not going to ask you to memorize this part. F of x goes to blank as x gets big. F of x goes to blank as x gets small. Okay, so we're going to look at this graph, y equals x, and we're going to describe it. Well, that's the graph y equals x. So as x gets large, I'm looking at this part of my graph, this part over here. As x gets big, what does my y do? Does this go to infinity or negative infinity? Infinity. What about as x gets small? As my x values go this way, what happens to my graph? Is it going to infinity or negative infinity? Negative infinity. So the moral of the story here is, if you have a function that's a positive leading coefficient and an odd exponent, then it's going to be end behavior just like this. So the only graph you have to know how to do is this one. Okay? You have to know that one. You have to know y equals negative x. So a function where the leading coefficient is negative and your exponent is odd. Y equals x squared. And y equals negative x squared. Okay, let me write that again. Y equals negative x squared. All of the graphs, when we're doing end behavior, have to be like one of these four. That's it. That's it. So let's say I had f of x equals 7x to the 6th. Now again, after that, doesn't matter what comes. It doesn't matter. -1, -1x, +3, anything. It's all about that leading coefficient and that first term and your degree of your first term. Okay, your degree of the polynomial. So we write this out because this is always the same. You want to find out what happens on one side of your graph and what happens on the other side of your graph. So first of all, which one is this like? Pick 1, 2, 3, or 4. Which one is it like? Well, my leading coefficient is positive and my degree is even. So that's going to be like this one here. So I have to describe this end behavior. What happens as my graph goes this way? As my x values go this way, what does my y go to? Infinity. What about on this side? What does it go to? Infinity. Okay. Y equals, I'm going to change y and f of x. We'll keep using them interchangeably so you can understand that that's the way that works. So y equals, I don't know, negative 8x to the 5th minus 7x squared plus 12. So I got to write out the form f of x goes to as x gets big, and f of x goes to blank as x gets small. So which of these four is this one going to be like? The leading coefficient's negative, the exponent's odd. Which of those is the leading coefficient negative and the exponent's odd? Right here. Ding, ding, ding. It's like y equals negative x. So I have to describe this end behavior. As x gets big, which is this part of my graph, what is my graph going towards? Infinity or negative infinity? That would be negative infinity. This part of my graph, as x gets small, so my x goes in this direction, my x goes here. What is my graph doing? Infinity or negative infinity? Infinity. Infinity. Okay, I'd like you to try these too. F of x equals, f of x equals, so let's say we have 6x to the fourth minus 7, that's 1. And the other one's going to be f of x equals negative x to the third plus 7x plus 1. And I want you guys to fill in the end behavior. Okay, infinity. I keep putting blanks over there. We don't need blanks over there. F of x goes to, as x gets big, f of x goes to, as x gets small. So please pause the video and give it a shot, and then we'll come back and look at the answers. And that'll be it for 6-2. That'll be it, mate. Okay, so you're back. What's one's this like? Which one's it like? Leading coefficient positive, exponent even, right here, ding, ding, ding. What's that going on this side? Infinity. What's that going on this side? Infinity, infinity, infinity. This one here, f of x equals negative x cubed. Which one is it like? It's like this one. Okay, it's like that one there. So let's look at what happens, okay? So we have to say what happens as we go to infinity. As we go to infinity, as we go to infinity, this is going to negative infinity. And as x goes to negative infinity on this side, this is going to infinity. How about that? Hope it made sense, guys. 6-2. If you have questions, send me an email. Ask me in class.